Good afternoon. We're back in the podcast cage here at Embedded World. I'm Rich Nass with Embedded Computing Design. I'm here with Julien Battiston of NXP. How you doing, Julien?
Hey, Rich. How are you?
I'm great, thank you very much. And I'm pretty psyched because you guys made a very cool announcement yesterday, and I would love for you to tell the audience about that.
Yeah, exactly. So yesterday we announced our first NXP Core-Ride Z248 zonal reference systems. And it's actually the hardware and software foundation of a 48-volt zonal ECU.
Okay, let me stop you there. Yeah. You said both hardware and software.
Exactly, yes. And tools and collaterals as well. So it's not that just we are bringing an object to the table, is we are also addressing 360 degrees, the development environment, the partner, the ecosystem. And the idea behind it was how can we simplify the transition to SDV and accelerate the time to market of the customers.
You're talking about a very complex topic to begin with.
Yeah, exactly. Yeah.
What are you doing specifically to make this easier for people?
Exactly. So if you look at the zonal architecture of an SDV, it has actually 5 key functionalities.
Well, let me stop you there. When you say zonal, explain that to people so everybody understands what you're talking about.
So actually, with the digital content growing in the car, complexity rises as well. And the way the industry has decided to tackle that complexity is to move from a traditional distributed domain controller architecture where you have 100, 150 boxes in the car. Every boxes is one functionality if you want to make it simple, to a kind of hardware centralization. So the goal is to reduce by a factor 10 the number of boxes so that the software development, the software upgrade, the software validation becomes easier. And zonal means those ECUs, the few ECUs that remains are distributed geographically in the car, and every geography deals with the feature set of that particular location of the car. So in general, in an SDV architecture, you have 3 to 4 zones, one in the front, one in the back, one left, one right, and they are all handling the functionality that are co-localized.
Okay? And how are those zones connected to each other?
In general, they are connected through Ethernet, and you have different types of topology of connections. You could have a kind of a star topology. Everything starts from the center and rise to the zones. But you also have the ring topology, where every zone is connected together through a kind of big Ethernet bus.
Everything's hardwired within the vehicle.
Sorry?
Everything is hardwired within the vehicle?
Everything is hardwired in the vehicle, yes.
And are we talking about mission critical applications within the vehicle as well?
Absolutely. Some of the zones, they deal with braking, they deal with steering, so the level of safety and compliance to agility is very high for those objects. And on top, since, like I said, they are responsible for the let's say the functionality that are co-located in their zone. It's not that they are only dedicated to one purpose. So the zone needs to handle the mixed criticality of the software and the different payloads they have to run. Some of them are real-time, some of them are non-real-time, some of them are safety, some of them are not safety. And that's why, as a semiconductor, we need to provide that technology for that. And what we have announced a year ago at Embedded World was the S32K5 family, which is our zonal, let's say, MCU for SDV. And it has a lot of, let's say, hardware features that will permit this hardware centralization and this mixed criticality, highly safety, critical software integration.
What do you say to the people who still think a discrete approach makes more sense, where they have 100 different zones within the car?
No, actually, I think the industry has realized with those fancy features that are coming in, especially pushed by the new entrants that have no legacy, that they need to revolutionize the architecture of the car. If you take simple features like the Sensory mode, which is the capability for your car to monitor its surrounding when it's parked, so that you can prevent thief attack. In a traditional architecture, you would have to modify 10 to 15 ECUs. In an SDV1, it's probably 1 or 2. So the pace of innovation, the pace of development, the maintenance through the hardware centralization and those SDV architecture is much simplified for the customer. So the total cost of ownership of an SDV architecture is really the way to go to sustain the rise to digital content and increasing feature set of the cars.
Very good. And you raised a very important point, security. How do we make sure that people aren't hacking into these vehicles?
So at OEMs, they have plenty of security measures. It spans over the complete EE architecture. And actually, with this NXP Core zonal reference system, we also simplify the security for zones. Of course, NXP is known for all the security assets that we have, but we are elevating that at the vehicle level, at the system level with the NXP Core.
Okay. And then what is the tool set that a developer would be working with?
So we are investing, so like we said, SDV, the first S means software, the second letter is D, means defined. So it's not just about providing a software that is final versions, it's about how you evolve the software at a rhythm, at a pace that is compatible with the pace of the industry. The modern way of developing software now is agility. So we are moving to agile, we are moving to lean, and we are also heavily investing in the continuous integration, continuous testing, continuous delivery infrastructures, so that we are investing in tools that are largely deployed in the community, open source community, and those tools will be capable to connect to the one of the customers, so that the deliveries we make every week can be easily ingested by the customer on a weekly basis, and then the feedback loops on the quality of what we deliver, the test in the context of the final product is going to be shift left to us, so that the quality of what we are going to deliver is going to improve much faster than in the past. And that's how we accelerate actually and simplify the time to market, while also reducing the investment at customer side.
Do you see that the industry is receptive to this approach?
I have to admit, and I'd like to stay humble as well. I'm touching, we have traction at customer that we did not imagine to have at this stage of the project. So, you were announcing today, the first official delivery that will fly to customer is planned for early April. And actually, we have already a handful of very important customers that have signed the evaluation letter and that are waiting for the first delivery.
Very good. Thank you very much, Julien.
You're welcome,
Appreciate
Rich.
it.
My pleasure.